Hey, it is showtime. Welcome to another rousing adventure of Chill Skills Sporlan Tech Talks. Thank you for joining us today. This is a recorded webinar. John, did I say recorded?
I believe you did.
Yeah, I think I did. This webinar will be recorded and it will be posted to our site for your viewing enjoyment. That way you can watch it over and over again. If you want to punish yourself, you can do that. This is part 3 of a multi-part series covering the S3C case control product line. Now I have to be careful not to call it the SC3 or C3S as some people do. No, can't do that. The topic for this episode is accelerated case delivery and how to mount and wire the control. And when I say control, I'm kind of using that for short to emphasize the S3C or the case control, if you will. Sort of as an abbreviation of sorts. Here's a shameless promotion for the next webinar that we're going to do. We will be releasing new episodes in relatively short order of this series, just like those other big streaming services, in approximately, I don't know how many weeks yet it'll be, we will post part 4 of the series of webinars on the S3C case control, and we'll tell you more about the fun stuff involving this relatively new product from Sporlan. And we're just going to keep going on with this epic until we have covered all the S's and C's in this deal. So that part 4 will be case startup and control systems overview. Please watch for an invitation. And here's the contact information specifically for the S3C tech support. This is what you have to do if you need help out in the field. So some people say, well, what about late night support? Well, look here. We've got from 1 minute past midnight, Monday through Friday, until 5 p.m. Eastern time, excluding holidays. Just take a look at the details there on the slide. We've got a phone number for you to contact. Now, don't be thrown off by this detail. The email here is a little bit different than our normal tech support because you're looking for S3C support, as well as the phone number here is a little different. Hello, I'm Jim Jansen, Senior Application Engineer. That's me on the left, but we're streaming a video, so this is kind of irrelevant because we're broadcasting our images these days. And joining me today is John Whithouse. He's my longest running co-host. All the rest of them have gone.
Let's not talk about that.
We won't talk about
Let's not talk about that.
John's a Senior Principal Engineer here at the Sporlan Division. He's a published author, consultant, and as I have said many times in the past, all-around extra smart guy. That means John's a big deal around here. I'm really glad to have him. You ought to say hi or something like that.
Hello, everyone. Great to be here.
And Phyllis is also in the room. She's our communications director. She tells us what to do and when to do it, and sometimes we actually pay attention to her. Phyllis, you ought to say hi as well. At least say hello.
Hello, everyone.
Now, this concept of accelerated case delivery was driven by some of these big box store retailers. Big retailers who are wanting to sell food to customers want to be able to replace old refrigerated cases or remodel or do a startup very quickly. The goal was in as little as a 1-day turnaround. In the past, this process may have taken 1 week or longer. That sound about right, John?
It does, yes, it does.
But in order to do this 1-day thing, 1 day or less, controls need to be pre-programmed with application information, set points, what refrigerant's going to be in the system, defrost details, and the list goes on. Now, this has had to be coordinated with case manufacturers for all this pre-programming, the implementation, testing, startup, with the end result being cool, cold, or frozen product ready to sell to customers in this really compressed schedule. Now, we needed the cooperation of all of these big case manufacturers. Many of them were involved in the first onset of this. For the case to be ready to be placed in the store and turned on to meet that goal of 1-day startup, we had to meet with these case manufacturers to understand the programming, the implementation, and testing and quality control, and so that it all matched up with what they've got in place. Now, here's a list of some of the tasks that would need to be completed at the refrigerated case manufacturer's location. For instance, the cases would be wired and tested. The S3C control, or simply the control for short, will be configured with settings specific to each case, to each application. This includes, among the things we previously stated, the case identification or case ID as well. Presumably, no additional configuration effort on the part of the installing contractor would be required at the job site.
That's the idea.
Yeah. The cases will ship to the store with a case identification ID attached to the case. Where? Well, in a location that's readily observable.
Yep.
This would actually be a placard or nameplate. And sometimes the case ID gets formalized after the case has actually been set in the right location in the store. And the case will have an assigned location based upon that case identification that's associated with it. And it needs to be in the correct location. Now, that case identification consists of a couple of things. It will be the physical placard or nameplate.
Yep.
And then what else, John?
The electronic entry for the control. So the actual electronic identification for that case within the control.
And that would make a lot of sense, right? That would have all the specific settings already programmed into it. This is the idea. And in order to then take the next step, which would be after things have been plumbed and piped and we're getting closer to being ready to flip the switch, pulling a vacuum on the system would be important prior to charging it with refrigerant.
Yeah, absolutely.
To facilitate that, valves need to be in an open position. All Sporlan EEVs and EEPRs, so that's the valves that are control superheat and pressure that are step motor driven, would ship from our factory with the valves at 50% open. So that helps inherently. Yes. Now, if the cases aren't wired up and powered, you can always use a magnet to open the solenoid valve if that's present, if the case has not been powered up, like we've said. If the case is wired and powered up, there's something called Charge Pro mode that is part of the control scheme, and that you could use that to force the step motor valves to 100% open position.
Yep.
And the liquid line solenoid to an open position. That would include the circuit EEPR and that liquid line solenoid valve. So that would be a handy thing.
That's a way to force everything wide open.
So that's that Charge Pro mode, and we will tell you more about that at another time. Now, just so you know, the case ID thing is a little more complicated than what we plan to get in today. And we will detail that in an upcoming webinar, including all the nomenclature and all that network lingo that goes along with it and the specifications and so on. But just remember this case placement and case location is a critical detail. Some cases are essentially duplicates of one another, except for some application details. I mean, John, you've been involved with that in the past.
Yeah.
And in order to meet any quick turnaround and startup goals, cases need to be placed in their assigned locations with the correct programming in place. This diagram that you see here is a so-called one-line diagram, which details all of that. And note the fancy maps pin icon we've got in here that we've added as a means of trying to bring more emphasis to that fact. So this one-line drawing details the exact case location, like the one we've shown here. Dimensional drawings, which will be a part of the overall project, would not typically denote specific case locations. So now what do we have here? The case ID needs to be consistent with the case label or placard and the case placement in the store floor area. This is a big deal. How do you determine the case identification or ID? Well, you could use the Tech Check app or the display module, and we will talk you through that process very soon, but not today. If the case gets placed incorrectly, and that can sure happen, what do you do to fix that, John?
Typically, in this case, you just want to move it. Get it moved to the right location.
Put the right case where it needs to go.
Yep.
What else could you do if that's not practical to do?
You can relocate the control, unplug it and reinstall it in the right case, or you could reconfigure the control. But that's definitely going to cost you when it comes to time.
So if you did go down that path, you're likely to need some help from our S3C tech support team if you're going to reconfigure the control, and if you decide to take that approach.
Indeed.
What if the control is incorrectly configured in the first place, or not configured at all?
Oh,
Stuff can happen.
It does happen from time to time.
Well, you could take the same approach.
Exactly. It can be configured at the job site or reconfigured. Shouldn't need to do it, but the tech support team can certainly help you take care of that.
Absolutely. Now, here we show some suggested locations for the following components. Here's the power supply, the so-called valve module, the S3C case control, or just control for short. Up here, we show the display module. And typically, the S3C control, the valve module, power supply, and even the display module would be factory installed by the case manufacturer. That helps to facilitate this quick turnaround. I know there have been times in the past when the display module would need to be field installed. Mm-hmm. What else are we showing on here, John?
Also, how to wire the liquid line solenoid and the EEPR, if you have those.
And we've got some more details concerning wiring the solenoid valve and the EEPR on a later slide. Now, here's something we get questioned about this, and I've even got some more details on this later. I realize that these electronic components are in a tough spot.
They are.
Now, keep this in mind.
Yeah, it's the very wide variety of case configurations out there and methods of construction makes it very difficult to come up with a truly common location for these types of items. So we have to be a little bit flexible about where we can put them.
Yeah, but then we go on to say, mount the case control and the valve module in a rain-tight protected location using either a flange of some kind or a DIN rail. Mm-hmm. That becomes a little tough to do sometimes.
It can.
The display module, we'd want that in an indoor location near the case, but outside of the refrigerated space where it's visible.
Correct.
It would be a nice thing. And what do we have here? We've got a slide that details the wiring of the network and shows how the different devices are linked together. Note here that we've also shown both the front and back of the display module, and we're just showing the network of the valve module, the case control, and the power supply. This network can support one display module, one case control, and up to 2 valve modules. And we talk about them being wired with 22 AWG, and we specify Belden 8723 or equivalent as far as the wire is concerned. We have a exploded detail here of the twisted pairs with the shielding that comes around it.
Right.
Now, Belden specified 2 twisted pairs with that shielding. Who or what is Belden? John, do you know?
Belden is probably the big name in cable manufacturing out there. Been around for a number of years and don't have any idea how many different types of cable and products, but they are kind of the industry standard. So it's typical to cite a product of theirs and say their product or equivalent.
Okay, so it's a standard for specifying wires on cable.
That's correct.
Now here we're showing some of the sensors that are needed to make all this work. The S3C control system uses input from several sensors to control case, discharge air, superheat, and defrost. It's important to follow these suggestions here, or instructions, to ensure proper location and mounting technique. All sensors should be provided by us, right?
By us,
Sporlan.
Absolutely.
If you want to make sure that they work and that they're compatible and that they operate as expected. We've got a torque requirement here of 3 to 5 inch pounds. We're specifying 18 gauge recommendation for extensions, while the standard sensor wire is anywhere from 22 to 24, and the transducer 22 AWG. What AWG? What is that, John?
American wire gauge.
Okay, so that's a standard, right?
Mm-hmm.
Yeah. Now, and what about this color code thing? Does Sporlan ship these sensors with these color-coded wires?
Yes, we do.
Yeah, and so what all do they mean?
So you would have blue for the coil outlet, green would be discharge air, orange for defrost termination, and yellow as return air.
Okay, I guess that's all good if you're not colorblind.
That would help, yeah.
And I would presume that this color coding sequence would be a big help in troubleshooting.
Certainly is. Yeah, if you have common color code there all the time, it definitely helps out when something happens.
We further go on to talk about that you can make an extension to 100 foot, and we talk about how to do that. And then we also have a warning here about route and secure cables away from things that might cause damage, like hot surfaces, high voltage lines, which can interfere, and
Correct.
Anything that's spinning, rotating, twisting around that could kind of damage it.
Yep.
Here's some detail on how to actually mount the bulb, if you will, of the temperature sensor. Again, they're not polarized. Piping must be on a horizontal free draining line, and that kind of sounds like we're mounting a bulb for a thermostatic expansion valve. We're kind of detailing the 4 and 8 o'clock positions on a refrigerant line. We also give you a more detailed view of how to do that. Here you can probably get away with zip ties, where we wouldn't recommend that for the bulb for a thermostatic expansion valve. These lightweight sensors can live with that.
Yeah.
Here we're showing how it would be terminated on the control itself.
Right. You're correct. You would not want to do that with a thermostatic bulb, but a lot of the other principles about where to mount them really apply very much the same.
Makes sense. Now, here we discuss the pressure transducer. We also need to manage things like superheat. You need both temperature input and pressure. And of course, you're interested in what's going on with pressure for a number of things. Here we have detailed one of our newer pressure transducers that we make available. And we talk about mounting it at the 12 o'clock position on a refrigerant line and torquing the sensor to 6 to 8 foot-pounds. And there again, we're specifying a Belden code, if you will.
Belden code.
Now, and then we got different case control or valve specifications here in this table. What would be important also with this, John, as far as spacing is concerned?
Well, you really kind of want to minimize that distance between the coil outlet sensor and the pressure transducer. You're using those two inputs to measure your superheat, and so the closer to the same position you're taking that, the better reading you're going to get on that.
So here, pressure transducer and the temperature sensor.
No more than an inch or two as ideal as that diagram shows, and then you want the coil outlet sensor at about roughly 12 inches give or take from the actual last two passes of the coil.
Makes sense to me. Now, here we talk about evaporator nomenclature. I didn't know we needed to have nomenclature for evaporators, but apparently that's important.
It is.
You see here how we identify evaporator locations and the associated control components in that refrigerated case. While you're looking at the front of the case, we have taken on the technique, if you will, of numbering them, the convention of numbering them from left to right as you're looking at the case from the front. Hence 1, 2, or 1, 2, 3. We can support up to 3 total evaporators in a case with a control and the associated extra components like valve modules.
Yep. Kind of makes sense. It makes sense, but we wanted to point that out.
Yeah. Now, this slide details the location of the termination points for step motor valves on both the case control and the valve module. Now you'll note that here in the slide, we refer to them as stepper valves. Here is the case control with stepper valve termination points for the black, white, green, and red wires. Also, we have the valve module, which is essentially an extension of the case control. And likewise, we have stepper valve 1 and stepper valve 2.
Right.
The first evaporator control lands on, the wires would land on the case control, as we've shown here. Now, if you contrast this with thermostatic expansion valves, you wouldn't use this location because there would be, say, no EEV to terminate here. And you could, in theory, what could you use that to do, John?
Well, I suppose you could also land the connections for the EEPR.
Okay.
If you have TEVs instead.
All right.
Yeah.
The S3C would need to be configured to accept that, but you can do it.
You could do it. Mm-hmm.
So now what happens to the second and third ones, if they exist?
So if they are in that installation, they would land on the valve module.
And if you're using a valve module, and if you happen to have an EEPR in conjunction with maybe an EEV, that EEPR would need to be landed up here at the stepper valve 2 location.
Correct.
This is just a requirement. That is, if you have a valve module that is going to be the control that's telling it what to do, and you've used this position for maybe an EEV.
Mm-hmm.
Now let's take a look at this slide, which adds more detail to that whole situation. And what's going on here, John?
So there are some added functions on the valve module. There are dip switches on the side of the module. You see none right there. There might be multiple valve modules on the job supporting different configurations. So that dip switch can provide an address or basically an identity for that module. It tells the valve module what type of valve will be landed on it or terminated to it. And if you note the position of the switches, with switches 1, 2, and 3 in the down position, an EEPR would be terminated on the valve module in the position of stepper valve 2.
Okay.
There are obviously other combinations there. And it helps to identify and address the valve and configure to use an EEPR in the system. So typically this would be in conjunction with EEVs being used in that same system. And if you don't position those dip switches correctly to identify that type of valve to it, the valve, it's not going to control that valve correctly.
It won't. Right. It will think it's something else other than what you want it to be. Now, let's review some valve and control combinations. Here's the control. By that, I mean the S3C and one EEV. This control method would allow the EEV to regulate superheat, and the control would also drive the optional liquid line solenoid valve to successive open and close positions and open and close the EEV in order to control the case temperature. The liquid line solenoid valve is listed as optional since refrigerant flow may actually be stopped by closing the EEV. Now, the optional part, what happens if you have a power outage?
Well, if it's a stepper EEV, you cannot be sure that you're going to have a closed valve in terms of power outage, and so that's where a solenoid valve comes in.
Yeah, so I kind of think of it not being such an optional thing. Right. I kind of like the idea.
Yeah. It's optional, but very close to mandatory.
Fair enough. Now here's the wiring diagram for that combination. This is the relatively simple wiring diagram for this method of temperature control. Note the presence of a power supply, the display module. Now where'd that liquid line solenoid valve go? There it is. We show how it's wired up with wires entering the junction box there. The EEV, here's the EEV. And then we've got the associated temperature sensors, pressure transducer, and so on. And all the other control functions like fans, lights, defrost, contactor, and so on. Here's another version. Here's the control in 2 EEVs. What's going on here, John?
Well, so in that situation, the valve module is basically an extension of the case control, and it expands the control's capabilities. This provides for additional inputs and outputs. Could be control for 2 EEVs or 1 EEV and 1 EEPR. And here it is needed for the second EEV. So the case control will control the typical case functions and collect the desired sensor inputs and drive EEV1. And then the valve module will collect the necessary inputs for the second evaporator and drive EEV2. And again, those EEVs will be used to regulate superheat.
That's what you'd expect.
Yeah. And then the coil out temperature sensors would typically be installed on each evaporator coil outlet with 1 pressure transducer on the common suction.
Okay.
In that case.
Well, just for fun, let's look at the wiring diagram for this example. Here you got like we said, the valve module simply extends the input and output capability of a single case control. If you take a close look, you'll see EEV1 and the sensors and pressure transducer terminations made at the case control. Likewise, for EEV2, those sorts of things are terminated on it. And we've included the second pressure transducer here to show this option and how it will be terminated on the valve module versus 1 pressure transducer on, say, a common suction. So there's that second pressure transducer. Now, here's an example with 3 EEVs. So there's 1, 2, 3. I can still count, and I didn't have to take off my shoes.
Excellent. Glad to hear that.
And here's an example of that wiring diagram. This is just an extension of what we've already seen.
Right. So in this one, if you'll notice, if you compare that to the previous one, you basically have the same things with just 1 more set of componentry over there on the valve module.
Yeah, over here. Now, let's look at another example. Here we get a little more fun going on. We're going to control an EEV and an EEPR. Even though the EEV can influence both discharge air temperature and evaporator superheat, multiple evaporators running at temperatures above common suction might just show enhanced performance if we included this EEPR, right?
Indeed.
The case control will handle the normal case functions and receive the necessary sensor inputs for the EEV, and the valve module, like we've said before, will drive the EEPR. The EEPR could regulate discharge air temperature, and the EEV will simply control superheat. That optional liquid line solenoid valve may be installed as 1 per case or 1 per lineup, if you will. And again, I've given my thoughts on the optional part of it. Each case in the lineup could theoretically be fitted with its own EEPR and valve module.
Indeed, they could.
And we'd sure probably like that if you'd do that.
Yes, we would.
Here's the wiring diagram. Note the termination or landing of the EEPR on the valve module. That's the valve module at the stepper valve 2 position. You know, it still bothers me saying stepper valve because I grew up saying step motor valve. It's kind of like thermostatic element and power head and TEV, TXV. I'm showing my age.
You'll get over it at some point.
Eventually.
Eventually.
Now, here's, as I promised, some more detail regarding wiring of the liquid line solenoid valve and the EEPR. We, in this situation, in this case, we show the EEPR being terminated directly on the case control. Now, how can we get away with that, John?
Well, the case control can be configured to handle this installation if thermostatic expansion valves are being used and not EEVs for superheat control. So that this would be a situation where a TEV is being used instead.
So there'd be an intermediate terminal block to facilitate the connections to make it simple. And you would have 120 volts. We're saying 120 volts because the design supports that voltage as opposed to others. And you've got the liquid line solenoid valve being wired, and then the termination points for the EEPR here on the terminal block. And then we show their corresponding landing spots on the S3C case control over here. Makes sense, right? Now, we're getting into one of my favorite parts of this whole thing. Questions that people ask over and over again. And they got a fancy word for that. They call it FAQ, or frequently asked questions.
Frequently asked questions.
Now, here it is from somebody I don't know. We continue to experience communication problems with the Sporlan S3C gateway. Is there anything we can do to fix this? And indeed there is.
Indeed there is.
Yes, the gateway may be disconnected from electrical power. What else could happen, John?
Could also be disconnected from the communication loop.
Okay.
Could be in an area of poor or limited cell reception, mobile reception.
Yeah, maybe it's on the store floor with a bunch of stuff stacked on top of it.
Could be. Could be damaged with an antenna broke off or something like that.
Here's my favorite.
May not even be in the store.
Yeah.
That's a dead giveaway right
is
there.
that it? Yeah,
that's a giveaway right
okay,
there.
so there's some answers to that. Now here's a tricky one. I've heard this being a problem off and on, and this is again from Anonymous. Sometimes this control thing, this happens. Which control thing is this, John? This is the display module.
That's the display module.
Sometimes this control thing gets stuck in clean mode. How do you fix it? Well, what happens in clean mode? What's going on with clean mode?
Okay, in clean mode, the valves are shut. So they are closed and the fans are turned off. So that is a way to shut things down to effectively clean the case.
All right. Hence the name clean mode. Now that might also happen. I think if a refrigerant leak is detected or something of that.
It could.
That could happen. And so it gets stuck in clean mode. So how do you unstuck it?
You would want to cycle the power to the
device.
Device, yes.
Disconnected from power.
Disconnected from power.
I love this one. It's the equivalent of rebooting the computer, right?
Basically,
isn't that how IT fixes everything?
Pretty much.
Okay.
Pretty much. So it's going to be the equivalent. If you go back enough years, I'll date myself. It's the equivalent of using the big red switch.
Fair enough. You could also use the display module with the little wrench that's depicted here, along with a passcode that we'd get to you to actually exit clean mode. And we'll talk more about how to perform that with the display module in an upcoming webinar. That's some tricky details, but it's neat.
Yeah, getting down into the weeds with that.
Now, here's a real valid question. Any plans on making these S3C boards water resistant? The manual states it cannot be mounted in a wet location. However, 75% of case manufacturers, the electrical boxes are under the cases. Good point.
Good point.
I know, even though we say to mount the control outside of the refrigerated space and in a dry location, unfortunately, and while this certainly would be an interesting thing to consider, there are no immediate plans to include this feature, even though it seems like it would make a lot of sense. A lot would need to happen in order to incorporate a water or moisture resistant enclosure into this current design. Unfortunately, no.
I think with good, with careful selection of a location for these, you actually can have them reasonably well protected. You don't want to get water splashing directly on them, but obviously, but I think with good selection of a location, you can keep them pretty safe.
Good. Now, here's another one. We really need to push new firmware out to the case control, but we don't have a cellular gateway in the store. Remember that cellular gateway that,
Yep.
What can we do? Well, it seems as though the cellular gateways have in the recent past been made from unobtainium.
Unobtainium, yes.
Or perhaps JIT was being employed. That concept of it just isn't there.
That's right. Right.
Well, here's a way to get around that. Here you go. You want to tell us about this, John?
Well, a little device called an Ethernet adapter. So if we want to review a little bit how to connect these components, This unfortunately only works with an iPhone or iPad. I don't think if you have an Android device, I don't think it works.
Yeah, I don't. It's my belief that's not the case.
But we're currently creating an instruction manual, probably one of the SD forms that we use for that product line that's going to explain how to do it in the field.
So you got the iPhone, iPad, you got this adapter, then you got an Ethernet cable over here to the S3C case control, and then you plug the thing into the wall if you need to do so.
Yeah.
Pretty neat.
Yeah, I think that's an optional thing because I think the phone can power it some, but I think it's pretty rough on the phone battery. So that's why you have that.
Could be. Now, coming up, this is my favorite question from our own internal people over and over. Was this webinar recorded? John, how many times do I say?
Gee, I don't know, Jim. Was this webinar recorded?
This webinar will be recorded. And here's where you can find it. On over here at this YouTube place and at our Chill Skills location. Maybe what we ought to do is put a QR code on here on this actual slide so somebody could take their iPhone and take an image of it and go right where they need to go. Just a thought.
That would be a pretty awesome idea.
Yeah, but guess what? We recorded this. And here's where you can go to find stuff. Here's the commercial, Sporlan.com. For product literature, virtual engineer, that's Sporlan's product selection program, and a whole lot more. And you can view an encore performance of this webinar and all the other ones that we've done.
Facebook or YouTube.
Yeah. And all I got to say is at this point, a big thank you to the whole team to help put this together. We couldn't do it without them. And that's Phyllis, Jen, Dennis, Brandon, of course you, John, and all the other tech guys that have helped us along the way. Our tech support team stays really busy trying to help everybody make all this stuff work. Remember, here's the next webinar that's going to come up. Give us a little time and we'll get it out there. Here's a little reminder for the contact information on how to get help from us.
And just keep in mind that is a little bit different from our regular tech support.
Yes, it is. Yes, it is.
As Jim noted earlier.
Yes.
Just want to point it out again.
Populated with experienced people that are there to help you, humans.
Indeed.
And this concludes our webinar for today. Thank you for joining us, and we'll see you again next time.
Thanks, everyone.